Today, we're going to build a REST API using Next.js 13 in the app directory. An API is useful when you need to share resources with clients other than your web app in Next.js. Think like mobile applications, command line tools, or maybe something that other developers need. This API will be RESTful, although there is some interpretation as to what exactly that means. Hi, I'm Ethan, a principal software engineer who's been writing and shipping code in the cloud for over a decade. I sold my previous SaaS company in 2020, and now I'm helping people like you build yours. So let's get started. For this REST API, I'm going to model it off of a restaurant-like schema. Think something like DoorDash, where there are restaurants which have a name, perhaps a description, a type, some rating, and then the restaurant has a menu, such as a full menu, a brunch menu, a breakfast menu, and then the menus have items in them, and an item has a name, a description, and a price. We're going to keep this pretty basic, and we're not going to be adding ordering or anything like that. However, this should give you a full understanding of how you can build an API that has a lot of those moving pieces. So before we dive in, what is REST? REST stands for Representational State Transfer. That's a complicated way of saying a server will respond to a client with the representation, what it looks like, of a given resource. That resource is the state. A resource in this context is basically anything the end user or end client will need to get their job done or potentially manipulate. In our API, that's going to look like the restaurant themselves, the menus, and the items on the menu. If you were to take this example further, it might include the user's orders and items in that order and which restaurant they're going to. Whenever you're designing an API, you need to understand what resources you have to share with the end clients. That's where you need to start with figuring out how you're going to build the API. And for a RESTful API, the best place to start is with your database and what that model looks like. So let's dive in. We're building this with Next.js 13. And I'm using Prisma as my ORM to manage a Postgres database and the schema within it. You don't have to be using Prisma, and you don't have to be using Postgres. These are simply technology choices that I like. Because we're using Prisma, it's very easy to switch out what the underlying database is. I also happen to have next-auth installed because I want to show how you can protect or use a user session in order to work with your API. So, what does our restaurant database schema look like? Right now in our database schema, we only have the user. We have to add in the rest of the model to build out our database. First, let's add the restaurant. A restaurant will have an ID, a name, an address, which is required, has to exist somewhere, and then an optional description. It also has some default metadata to make managing it easier. We'll then add in a menu. A restaurant will have many menus. This is going to be like the brunch menu, or the lunch menu, or the dinner menu. Restaurants tend to manage multiple menus, and they might cycle out depending on the day or depending on the time. A menu has a name, an optional description, and then which restaurant it belongs to. Lastly, a menu has several menu items, and this is the actual thing a user would order. A menu item has a name, an optional description, and a price. We're modeling the price as a float, but keep in mind, if you're actually working with currency, you might be better off modeling the price as a string or using the underlying database's currency functionality to make sure you don't have floating point errors. But for this API, we're not going to worry about that. All right, with our database schema updated, let's go ahead and recreate our database model. I'm going to run a new migration here, and it's okay to reset all the data. Now, after the migration has been run, we're only seeding a user, which means our database does not have any test restaurant data. To fix that, we need to add in restaurants that have a name, an address, and an optional description. Let's ask ChatGPT to make some of that for us. Thanks, ChatGPT. Let's go ahead and copy that code and update our seed file. With that done, we can go ahead and reseed. And now if we go ahead and take a look at the database schema, we have our test user and we have our 7 test restaurants. Fantastic. Now we can start building out what the API looks like. When building an API, I like to design what the URL structure is going to look like and what it's going to return before diving into the code. This is going to make the actual code writing very easy because we know what each route has to do. The first thing our users are going to want to do with this hypothetical restaurant API is they are going to want to get a list of restaurants. Here, we're using the HTTP verb get, and the URL will be restaurants. And we'll have a prefix of API for all of these routes. This is going to return a list of restaurants that the user can then iterate over and display as they need. The next thing they're going to want to do is they're going to want to get a specific restaurant. This is pretty common where the list of all the restaurants might not have all the information because that might be a very expensive query. And when you ask details about a specific restaurant by its ID, then that request might return additional information. It's also nice when a user is loading a specific restaurant page, we know what the ID is and we can look up the restaurant by that ID and only return that information. This covers the read part of our API. We have the create, update, and delete, which we're gonna do next. To create a restaurant, we'll do post/restaurants, and this will create a new restaurant. We don't use the ID here because we don't have an ID yet. We're creating a new restaurant resource. To update with both put and patch, we'll have it at /restaurants and then use the ID to identify the restaurant we're updating. Lastly, the delete command to remove a restaurant is going to be the HTTP verb delete, and we'll pass in the ID. So with the API defined, we can now write this into code. In the app directory, under the API folder, here we have our next authentication, but we're gonna create a new file, restaurants, route. And here, we're going to export just get for getting all the restaurants and post for creating a new restaurant. And now to test the API, I like to build out the different requests we're going to use in a tool like Insomnia. All right, we're off to the races, starting to build our API. Here, we're doing /API/restaurants, and we're returning an array of all of the restaurants that we have seeded in our database. Let's go ahead and create a new restaurant. And we got the response that we expected. A 201 created with the restaurant information. And if we go back to list restaurants and remake this request, here it is at the bottom, showing that we not only can fetch the restaurants, but we can also successfully create restaurants. Now the only thing left to do is to fill in the rest of the API for put, patch, and delete. We have to make a new file. And we're using the dynamic routing to get the ID parameter from the URL. And here, instead of getting all restaurants, we will get the restaurant by the ID. To get the dynamic segments from a URL, you have to look up the params as a second parameter that's passed into the function. Here, the parameter we're reading from the URL is always going to be a string because it came from the URL. So let's parse it into an int. And now we can test. For this, we'll just fetch the first restaurant. And there it is. Now on to update. Well, that seemed to work perfectly. Let's give it a shot. This updated the resource, and the code's doing exactly what it should do. But we're getting into very specific semantics between put and patch. Semantically, the put endpoint these days tends to mean I am replacing the entire resource with this data that I'm sending you. And the patch HTTP verb means I am replacing partially what the information is, and I'm only sending the bits that I want updated. Here, while we're passing in all of the JSON that the request sent, because the user might not have sent all the JSON, this is functioning much more like the patch verb. Because we're using Prisma, Prisma distinguishes between undefined and null. If the key is null, it's going to set that value to be null in the database. If the key is simply undefined or doesn't exist in the first place, Prisma is going to ignore that update completely. Now, how you handle this in your API is up to you. Most of the time, people want something a little more like patch these days than put. But to make this a little more semantically correct, we're going to go through and change the update to actually remove things if they weren't included in the request. Here, if the data was not sent, we're going to explicitly set it to null. Now, this is going to break if the user doesn't send the name and the address, because we mark those as required. So if we run our request again, we're going to get a 500, which if we looked in the log, the argument says that address must not be null. So now it's doing exactly what we want it to be doing. Well, maybe it could have a nicer error message, but functionally, it's doing what we want it to do. Let's go ahead and write patch and delete, and then see where we're at. And then we can test. Perfect. And then if you run the delete again, it's gone. We're now starting our restaurant list at restaurant number 2. Excellent. So now we are covering all of the HTTP verbs and the various CRUD, create, read, update, delete parts to our API for the entire restaurant section of our API. Let's go one level deeper and add in the menus. A restaurant might have many menus, right? One for breakfast, lunch, and dinner perhaps. We're not going to do this for all of the restaurants because that's a lot of menus to add. Instead, we'll just pick one restaurant and add some data to our database for that particular restaurant. Yo, ChatGPT. We'll add these menus to the first restaurant and then reseed our database because, well, don't forget we deleted the first restaurant. If you're running these commands, you might need to reset your database so all of the objects in it are removed. And now in our database, we have our number 1 restaurant back, and it has a menu of breakfast, lunch, and dinner. So now we can build the next section of our API. This is going to represent the menus which belong to a restaurant. Now, because a menu always belongs to a restaurant, they're not an independent resource. And that means we're going to nest them underneath the restaurant URL. So whenever you're referring to a menu, you're always referring to it in the context of its restaurant, which means the URLs are going to look something like this. Here, the API looks very similar. It's basically an extension of the restaurant API. You're going to ask for a restaurant and a specific one, and then you're going to ask for all of that restaurant's menus. And then you can ask for one specifically, and then to create one, you'll hit this endpoint, and to update or delete it, you'll use the ./menus.menuid. And so you can see how the REST API builds on itself. Now, if you have a resource that's totally orthogonal, perhaps something like a chef that exists outside of our restaurants, You don't necessarily have to nest that underneath the restaurants. You could just have an endpoint for /chefs. So take some time when designing your API to think about how the resources relate to each other and what makes the most sense. Again, in our API, a menu has to belong to a restaurant. So it doesn't make sense to have that be a top level resource because you would always be passing in the restaurant ID. Here, the restaurant ID, the scope of the menu, is elegantly provided in the URL itself. All right, let's go ahead and build it. And now we can test fetching a menu and creating one. Perfect. Let's create a new one. Uh-oh. Wrong key name. Perfect. Success. So now it's relatively simple as well to go through and build the rest of the APIs we need. Just keep in mind, you can't use the same parameter name. Since we're already using ID, we have to specify something differently. We'll use menu ID. And now we can test these as well. Fantastic. We've extended our API to now include all of the menus that belong to a restaurant. You can see where this is going. The menu items belong to a menu. And so we're going to have to nest the items underneath the menu in the URLs. Now, it's basically the exact same thing again and again and again. So I'm gonna leave that up to you to finish off if you're building something like that. Or you can check out the code down in the description and you'll be able to get the final result of this and see what I've done there. But if you followed along and built this, it's going to look very similar. There's a couple other things I want to talk about though before we wrap this up. The first one is that when you start dealing with lots of information, you can't return all of the data in a single list. That works for 10, 20, 50, 100 items. But if you're dealing with thousands of pieces of information, like DoorDash and how many restaurants they have on their platform, you're going to have to include some form of paging in your REST API. Jumping back to the restaurants endpoint, where we list out all 7 restaurants we have, let's go ahead and add paging. Now there's 2 types of paging you can add. One is offset-based paging, where you say how many you want, and you also say what the offset is. That's what we're gonna go and implement here because it's very easy to get started with. However, there is a performance hit. If you want to offset by 200,000 records, the database still has to traverse that many records. And so the other way you can implement paging is by using a cursor. Now, some databases have cursor-specific implementations, such as Postgres, which makes it very, very performant. However, Prisma implements a much simpler cursor strategy where it uses a primary key as its cursor and then will jump to that place in the database. So depending on your needs, you might pick one of those 2 strategies. Again, for this simple API, we're gonna go with offset-based paging. To implement the paging, we're gonna pass in the skip and take parameters that Prisma needs as query parameters in the URL. And then we'll pass them through to Prisma. Instead of using the regular request object, which is a web standard, Next.js augments the object with a couple of nice helpers, and that's in their next request type. So go ahead and change your request to next request if you have to get something like query parameters to make your life a little easier. Now that we have skip and take, we can go ahead and pass it through to Prisma. And now we can give it a try. Here, I've added skip equals 2 and take equals 2 to the URL. And so you can see it starts at ID number 3 and only took 2 objects. So now the client can use skip and take to implement their own version of paging. Another small thing you might want to do is you might want to check to see if a user is authenticated before doing some sort of action in the system. For example, you only want users to be able to create restaurants. Now anybody can fetch a restaurant, but only a user should be able to create one. Because we have next-auth set up, we can simply check to see if a user has a session and then go ahead and either return a 401 or let them complete an action. Here, we're getting the session, and then if they don't have one, we're returning null. Which means in our create restaurant test, because we have no session here, we're now going to get a 401 unauthorized. You could also check for roles if you have those in your session. Something like session user role does not equal admin. Lastly, I want to talk a little bit about the structure of data in our REST API. Traditionally, historically, a REST API would not only return the data, it would also return URLs that a user could use to look up other data or perform actions on the current data. For example, our endpoint that returns a single restaurant returns this, and that's the top level object it returns. But traditionally, the REST API might include other URLs to other resources. And so they would nest this underneath a data key, like this. And now the data is underneath the data key, which allows there to be other top level keys for other resources. For example, links, with a link to self, which is this object, and a link to get the menus for this object as well. By having the API be self-descriptive, the client only needs to know how to get the first resource and then can use the various links and actions to be able to traverse the API without knowing any additional information. Now, I have seen APIs that follow this REST pattern to the T. And let me tell you, that did not make them easier to work with. When building an API, remember, you're building it for clients. You're building it to solve a specific problem. By trying to be super die hard and follow an implementation or pattern, you may find that that is detrimental to the problem you're actually trying to solve. For example, if a client were actually using our API, they might ask you, hey, when we display a restaurant, we also want to show the most popular dishes at that restaurant. Could you give us a way to get that information? Now you could add that as a new endpoint. And so you would have to make a request to get the restaurant, and that would return this information. And then a request to restaurant's ID popular might return the popular dishes. But if a user is always using the popular dishes when they're displaying it, it might make sense to just nest the popular dishes within the restaurant object itself. Now, that might be a different table in the database. You might need to do some querying to pull out the dishes and calculate which ones are most popular. It very well could be a totally separate resource. But depending on how the clients are using it, you might want to tweak your API implementation to better suit their needs. Remember, you're building this to solve a problem, not to make the most puritanical API ever. When I always have questions around design or how to implement something, I tend to like to look to see what other great companies are doing. For example, I think Stripe does a great job with their API. And if you look at their API for, well, retrieving a customer object, you can see that their response includes some nested IDs, some nested settings, nested metadata, and it does not include any of the links to other resources. Here, Stripe is relying on its API documentation and client libraries to best guide the user. I think for the modern age, that's the better strategy to go with. And with that, you've created a REST API end to end. You can now go ahead and tweak these resources and build an API that your clients need and that you need for your application. Remember, if the only consumer for your app is your own web app, you generally don't need a fully fledged REST API. You can get away with just making the endpoints that you need. But once your clients are outside of your web app, that's when an API is very, very useful to have. That's it for now. Until next time, happy coding.